In continuing with the theme of how we prepare our students to become mathematicians who engage with the mathematical practices instead of memorizing algorithms and answers, we're going to be learning about fact fluency today. Fact fluency, as described by the Common Core State Standards, is the skill of carrying out procedures flexibly, accurately, efficiently, and appropriately. I recognize that might sound overwhelming, but it's my hope that everyone walks away from today's class with a clear image of what that looks like. Before we do that, though, let's take a moment to look at what fact fluency is not. I saw this meme on Instagram back in the fall, and it really resonated with me. Many of you probably spent your elementary school years just like me, taking timed tests just like the one we see here on the screen. And you also probably felt anxiety over them, just like the meme indicates. Timed tests, flashcards, and apps like Extra Math are actually enforcing fact memorization, not fact fluency. Students learn the answers to a fact, but don't engage with procedures in the slightest. When teachers promote and utilize these timed tests or extensive use of flashcards or extra math, students experience a heightened sense of anxiety over mathematics. It can be so heightened that it can turn them away from mathematics completely. Additionally, students struggle to retain their facts over time because they didn't actually learn what the facts meant. They just memorized the answers. Teaching fact fluency, though, does not increase anxiety and actually increases retention of facts. So now let's spend the remainder of our time looking at what fact fluency actually does look like. Fact fluency is a process that occurs over the course of 3 phases. All students will begin in phase 1, which is counting. During this phase, you will see students count on their fingers or on tools to find the answer to a fact. From phase 1, students will progress to phase 2. Students will begin deriving, meaning they will use strategies to find the answer to unknown facts from known facts. It's important to note that students will not progress to phase 2 without explicit instruction on these strategies. That's where the teacher comes in. Lastly, students will move to phase 3, which is the time when they're able to generate the answer to a fact efficiently. So, to move from phase 1 to phase 2, there is a lot of instructional coaching on strategies. Teachers are creating fact strategy walls. They're teaching students a wide variety of strategies. To move from stage 2 to stage 3 requires ample practice with these strategies. That comes by having students play games, having students engage in meaningful activities with one another in which they're asked to use the strategies to solve and show their work. In phase 3, it will often appear that students have memorized the answer. However, that's not the case. They have become so adept at using the strategies that they are actually doing the strategies in their head that quickly to produce the answer. It's amazing. Before we move on, I want to discuss one common misconception, which is that students can only be in one phase of fact fluency at a time. It's not true. For example, a student named Sarah might have reached phase 3 with her 2s, 5s, and 10s multiplication facts. But when it comes to her 3, 4s, and 6s, she's in phase 2. She's using a lot of strategies based on what she knows from her 2s, 5s, and 10s. And she might just be at phase 1 with her 7s, 8s, and 9s. That is completely normal and expected. Now, I'm going to break down what these three phases look like in both addition and multiplication, because both subtraction and division strategies rely heavily on fluency with addition and multiplication first. The Common Core State Standards have content standards regarding fluency in second and third grades. Second graders are supposed to leave second grade with the ability to fluently add and subtract within 20 using mental strategies. Likewise, third graders are supposed to fluently multiply and divide within 100 using strategies such as the relationship between multiplication and division. So let's take a look at what these mean. We're going to start by breaking down addition. In phase 1, students are counting on from the initial add end. This can look like counting on their fingers, using manipulatives like teddy bears, and counting each of the teddy bears, or using a number line as we see below. The student in this case would start at 4 and count on 5 to reach the sum of 9. When a student moves on to phase 2, they will be using a known fact to help them solve 4 plus 5. One of the first fact strategies that first and second graders gain mastery of is doubles facts, in which the addend is repeated. So to solve 4 plus 5, the student will replace the 5 with the number 4 because they know what 4 plus 4 is, and it's 8. Then they will think about what was the difference between that 5 and the 4. Well, they had to take away 1 from the 5, so now that means they have to add 1 to their sum of 8. When they do that, they'll get their answer 9. In phase 3, the students may use that same strategy of substituting the 5 with a 4 and then adding on the 1, but it's all done in their mind, and they will do it so quickly that the student is able to answer the problem with no hesitation. Let's now take a look at what this looks like with multiplication. One of the first strategies taught with multiplication is building arrays. In this case, the student built an array of 3 rows with 4 in each to match the multiplication problem 3 times 4. In phase 1, you will see students building this array and counting each figure in the array to reach the product of 12. When learning multiplication, students will generally learn their 2s, 5s, and 10s first, since they have such practice with skip counting. They generally reach phase 3 with these facts first, and then they use these facts to solve their unknown facts. Students will often use the 2s to help solve the 3s, as seen here. The student did not know the answer to 3 times 4, but they did know that 2 times 4 is 8. Building off the image of the array, they know that 3 times 4 has one more row, 4. So they will add 4 to the product of 8 to figure out that 3 times 4 is 12. Lastly, students will reach phase 3 of fact fluency, in which they are able to produce the product of 12 with little to no hesitation. Just like addition, they are using that strategy of using 2 times 4 and adding a group of 4 to reach the product of 12 very quickly, and it's all done in their head.